Okay, so this is the mid-unit 4 assignment, and right now we're going to do question 4. So what it's asking is, using the given information, find the equation of the graph. So by looking at this, it has one peak and two troughs, and it begins with a trough and ends with a trough. Therefore, we can conclude that it is y equals negative cos of x. And then there's many transformations applied to this. So we have the equation y equals negative a cos, and then in brackets k, and then inside more brackets x minus d, bracket plus c. So now we have to find the values of a, k, d, and c. So for a, you take the maximum y value and subtract it from the minimum y value. So that's 21 minus negative 24, and then you divide that by 2, and I got 22.5. Now we're going to find k. So k is 2 pi over the period. So the period of this is 12 because there's 12 months, and then you can simplify that to pi over 6. And then I found c. So c is the maximum y value plus the minimum y value, and then divided by 2. So that's 21 plus negative 24 over 2, and you get negative 1.5. And then lastly, we need to find the d value. So d, if you're looking at this graph, you can see that it is shifted 1 unit to the right. Therefore, d equals 1. So we have the final equation, which is y equals negative 22.5 cos bracket pi over 6, and then in smaller brackets x minus 1 brackets minus 1.5. Okay, question 2. Question 2 asks, a Ferris wheel has a diameter of 10 meters and takes 24 seconds to make one revolution. The lowest point on the wheel is 1 meter above ground. Sketch a graph to show how a rider's height above the ground varies with time as the Ferris wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. Okay, so here is my sketch of the graph. So it's 1 meter above ground, and this axis is time, and this axis is height in meters. Okay, question B asks, or part B asks, write a trigonometric equation that describes the graph. Okay, so I wrote down my maximum and minimum. So my maximum is going to be 11, because the diameter is 10 and it's 1 meter above ground. And then my minimum is going to be 1, because it's on the wheel and that's 1 meter above ground. And then I need to calculate my A, K, D, and C value. So that is A equals 5 when you subtract the maximum from the minimum and then divide by 2. My K value is 2 pi over P, and the period is 24 because that's how long the ride is. And therefore that simplifies to pi over 12. There is no D for this equation. And for C, that's maximum plus minimum divided by 2. So that equals 6. Then we write that out into one equation right here. So y equals and also the graph right here is negative cosine, because cosine is peak to peak, and this the graph they gave us is trough to trough, so we have to reflect it on the x-axis. So therefore our equation is y equals negative 5 cos bracket pi over 12 times t plus 6. Okay, part C. Check the accuracy of your equation by using t equals 12 seconds. Explain why this provides a check of the accuracy of the equation. What are 2 more values that would provide a good check? So what I did was I inputted 12 into t, and I ended up with 11, and that's what I expected. because 12 is halfway through the ride, and that's when you would be at the top of a Ferris wheel. And at the top, as we said before, the maximum is 11, so that makes sense. And two more values that would provide a good check could be either 0 or 24, because that's when we'd expect it to equal 1 for both of those. Okay, so this is question 3. And the question is, the height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meters at 12:08 to a height of 7.3 meters at 8:21, measured with a 24-hour clock. Assume that the height h of the tide can be modeled as a cosine function of the time of day t, and then determine the equation in the form h to the t equals a cos bracket k and inside brackets t minus d bracket plus c, where h to the t is the height of the tide at the pier in meters and t is the time of day in hours. Okay, so what I did was they give you the maximum and the minimum. So maximum is 17.3 and the minimum is 4.5 meters. And then for the a value, it is the maximum minus the minimum divided by 2. So that gives me 6.4. For the c value, it's 17.3 plus 4.5 divided by 2, which equals 10.9. And then the difference between the maximum and the minimum period, which is 2:08 to 8.1, is half a period. So it's 8 minus 2, which equals 6 hours, and then 21 minus 8, which is 13 minutes. This is a problem because I needed it in hours, so I converted it to hours, and you get 0.217 hours. So you add those two, and you get 6.217 hours. And this is only for half a period, so we have to multiply by 2 to get the full period, which is 12.43 hours. And then k equals 2 pi divided by the period. So that equals pi over 6.22. And then for the d value, because it's a negative cosine graph, it is moved over to the right by 2 hours and 8 minutes, because that's when the minimum happens. So therefore you have to convert 2 hours and 8 minutes into only hours, so that's 2.13, and that's your d value. And then here is the equation we get when we compile all this information together. So you got y equals negative 6.4 cos, and then in brackets pi divided by 6.22, and then in smaller brackets t minus 2.13 brackets plus 10.9. Okay, so part C asks, determine the height of the tide relative to the pier at 11:30. Give your answer to the nearest 0.1 meter. Okay, so I needed to convert 11:30 into hours. So that's 30 divided by 60 equals x. So x equals 0.5. 11 plus 0.5 is 11.5 hours. Now I input that into my equation that I just made, and I'll get 12.3 meters. Okay, so question D. A boat needs a depth of at least 12 meters to dock at the pier. Use a graphical approach to determine whether the boat is able to dock and when it must leave. Okay, so I drew the graph h of t here, and pretty much it has to be greater than 12 here for it to dock. So by looking at this, you can see it's between 5 and 11, and then if it was extended for the 24-hour clock, it would be between 18 and 2300.